Hello viewers, welcome back to my YouTube channel. If you come across this question on the forthcoming JAMB 2025 on simple harmonic motion, this is how you are going to solve it. Let's dive into it. What is the frequency of vibration if the balance wheel of a wristwatch makes 90 revolutions in 25 seconds? Option A 0.01 Hz, option B 0.04 Hz, option C 2.27 Hz, option D 3.60 Hz. Now the first question you're going to ask yourself is, what is the frequency of a vibrating body? The frequency is the number of complete oscillation that a vibrating particle makes in 1 second. The number of complete oscillation that a vibrating body makes in 1 second. That is, frequency is equal to what? Number of complete oscillation all over time. Okay, now from the question I'm giving how many oscillation? I'm giving 90 revolutions or oscillation. The time is given as 25 seconds. All right, so the frequency is equal to n over what? T, right? Frequency is equal to 90 over 25. Now what can go? You can reduce it to its lowest term. 5 into this is going to give me what? 5. 5 into 90 is going to give me what? 18. Now this is 18, right? So by the time I divide this, 5 into itself 1, 5 into 18, I'm going to have what? 3.60 Hz. The correct answer to this question is 3.60 Hz. And the answer is option D. If in a simple pendulum experiment, the length of the inextensible string is increased by a factor of 4, its period is increased by a factor of what? Option A is 4, option B is pi over 2, option C is 2 pi, and option D is 2. Now looking at this question, what are we going to do? We should remember that the period of a string of a simple pendulum is proportional to the root of what? The length of the string. Is that clear? Now for us to work it out, we say that this is a constant. This is equal to k root of what? L, right? Now if you make k the subject, to divide both sides by root of L, root of L. This cancels this. So T over L, that is T1 over L1 is equal to what? T2 over what? Root of L2. Is that clear? Now going by what we have, they say the length of the inextensible string is increased by a factor of 4. That means that my L1 is equal to L, okay? Then my L2 is equal to what? 4L is equal to 4L, all right? Now each period is increased by a factor of what? That means that my T1 is equal to T, then I'm looking for what? T2. That means that my T1 is equal to T and I'm looking for T2. Now let's go again. So what do we have? Instead our formulas by saying, substituting into what we have, that T1 is equal to T and T2 is what you are looking for. So let's go. We say that T, which is T1 over root of L, then is equals to T2 over root of what? Over root of 4L. Is that clear? Now something is common. What is common? Now we have that this is T over root of L is equals to T2 over 4 is the perfect square. Bring it out, we have what? 2 root what? L. Is that clear? Now this cancels this. So what do we have? We have T is equals to T2 over what? 2. And because you're looking for the new period, this is over 1, cross multiply. Therefore, my new period is equals to, now my new period is equals to 2 multiplied by the initial period, right? That means that the period is increased by a factor of what? 2. Is that clear? Now from what we have done so far, the correct option to this question is option D. I hope that is clear. In the diagram below, which of the following pendulum resonates with P when set into oscillations? we have pendulum P, Q, R, S, T, and U. And the options we have: option A, we have T, option B is U, option C is R and T, and option D is Q and R. Now, this question is under mechanical resonance. In mechanical resonance, the one that resonates with each other, or the one that oscillates with each other, is the pendulum that is of the same level with each other. Now, looking at pendulum P, the one that has the same height with it is pendulum T, right? So it's two of them that is going to resonate at the same time when set into what? Oscillation. You understand? This one is going to resonate different direction with this. This one is going to resonate differently from this, like as the others. Okay, so the one that has the same length with the pendulum we are considering is one that's going to resonate together when set into oscillations. So with that being said, the correct option to this question is option A, which is what? T, because T is of the same level and of the same height with P, so they're going to resonate together when set into oscillation. I hope that is clear. A simple pendulum 16 meters long has a period of 8 seconds. What is the period of a similar pendulum 9 meters long? Alright, so let's start by saying that the first length of this pendulum is 16 meters and the period, which is what? T1, is 8 seconds. Now we are comparing with another similar pendulum that are looking for the period, okay, but the length, which is second length, is equals to 9 meters. Now what you are going to do is to state our formula by saying that the period of an oscillation divided by the root of length of the period. Now this is the first one, the first period and the first length, then we are equating it by the t square over root of what? L square. Is that clear? Alright, so let's put in what we have. The first period is 8. 8 over the first length is root of what? 16. Then is equals to the second period is what you are looking for. That is t square all over the second length is root of what? 9. Alright, so let's work it out by saying, bring it out. Now this is 8 divided by the root of 16 is equals to 4. Now is equals to t square all over the root of 9 is equals 3. Is that clear? Now we can do cross multiply. If we say cross multiply, then t square is equals to what? 8 times 3 divided by what? 4. Is that clear? Now if first you divide this F1, first you divide it is going to give me what? 2. So the second period is 2 times what? 3. Of which we are going to multiply to get the period to give us what? 6 seconds. I hope that is clear. Now from what we have so far, the correct option to this question is option A. A boy timed 30 oscillations of a simple pendulum thrice and obtained 1 minute 10 seconds, 1 minute 12 seconds, and 1 minute 7 seconds respectively. The mean period of oscillations of the pendulum is what? We have option A to be 0.14 seconds, option B to be 0.43 seconds, option C to be 2.32 seconds, and option D to be 6.97 seconds. Now, for us to solve this question, you must get the period for each of the pendulum, right? Now, for us to solve, we have T1 is equals to the time of a number of complete oscillation, right? That is the formula for period. Then the first time is given as what? 1 minute 10 seconds divided by what? 30. Now let's work it out. 1 minute is equals to 60 seconds plus 10 seconds, right? Which is going to give us 70 seconds. Now divided by what? 30. Okay. Now I'm going to have 70 over what? 30. Is that clear? Now by the time I divide, I will have this to be what? 2.33 seconds. 2.33 seconds, right? Then for this next one, that is T2, I'm going to have, this is T2 over N. And my T2 is 1 minute 12 seconds. So this is 1 minute dot 12 seconds divided by what? Number of complete oscillation, which is 30. And 1 minute is 60 60 seconds plus 12 seconds, okay, over what? 30, right? Now what do we have? We are going to get 72 over 30. When we divide, we have 2.4 seconds, right? Then for the third one, T3 is equals to T3 over what? N. That is 1 minute dot 7 seconds all over 30. So what do we have? I have 60 seconds plus 7 seconds divided by what? 30, right? It's going to give me 67 over 30. That will give me 2.23 seconds, okay? Now for us to get the mean means adding them together, dividing by 3. So the average, the T average is equals to what? T1 plus T2 plus T3, right? Divided by what? 3. That means I'm going to add all of them together and divide by 3, which will give us what? 2.33 plus 2.4 plus 2.23 divided by what? 3. So I'm going to add them together to divide by 3. Let's see what we'll have. It's going to give us 6.96. Then we'll divide it by what? 3. And the final answer becomes 2.32 seconds, right? Now this is how we can solve it. We are going to get the individual period of the oscillation. We have the first period, the second, and the what? Third. By the time we add them together, divide it by 3, that becomes the mean period of the pendulum, right? And from what we have gotten so far, the correct option to this question is option C. If this video was helpful, please don't forget to subscribe to this channel, comment and share so that I can get to other students that are preparing for the forthcoming JAMB 2025. And if you have anything that you want us to explain, if you still want more explanation on what we have done so far, or if you have a particular topic where you have issues understanding in physics, why not join this community so we can see how we can help you overcome this phobia you have in understanding physics. I'll see you next time in the next one. Bye for now.